This session we're going to see how to generate a square waveform in 8085 microprocessor by writing an assembly language program, ALP. So we're going to generate an analog waveform, which is a square waveform, using 8085 microprocessor, and we're going to write an assembly language program here. So generally a square waveform can be generated in this way, either like this or like this or like this. That means you can see the differences in all three. One is, I say it starts at some minus 5 volts, one it starts at plus 5 volts, and one it starts at 0 volts. So we have three references here. In order to code the references, let's take three values here. So when I say 0, 0 in hexa, here it represents your minus 5 volts. When I say FF, I represent it as plus 5 volts. And when I say 7F, I represent it as 0 volts. These are the three references what we have here. So with this, let's generate this waveform, first waveform. Let's write an ALP for that. So how do I start here is 0, 0 is minus 5 volts. So I say that MVI A, 0, 0. That means you're starting at minus 5 volts here, as I pointed here. You're starting at minus 5 volts. So after it starts at minus 5 volts, you have a delay here. If you want to see that minus 5 volts, you have to first out that value. So you make use of a port address. It's an 8-bit port address. You're outing that value out C0. So C0 is your 8-bit port address. Through that, you're outing that value. That means what? It comes and stays here. So it comes and stays here when you out that value. That is at minus 5 volts. Now, after that, you want to delay. So this is your delay. You're going to generate a delay. Maybe it is a 0.5 seconds or 1 seconds. Whatever seconds delay you want, you can generate. Here I'm introducing the maximum delay. Maximum delay means the highest 8-bit delay count is FF. The highest 8-bit delay count. So 0 to FF is your delay count. So I write the next instruction as call delay. So call delay. I'm calling a delay subroutine. So let's look in for that delay subroutine. So what is that delay subroutine? Here I write that delay subroutine. So I'm moving the maximum count, that is FF, to the register. So MVI B, FF. So that is my delay count. I'm moving that to register. So you go to FF directly. You go to FF directly. So it is calling, you're calling a delay subroutine, and delay subroutine, it is a subprogram. It is going to tell about the delay count. So I'm going to have this delay as FF delay. So I'm moving FF to that. So it starts from FF. From FF, it starts decrementing. So how is that delay is here? So this is your 0 to FF. So I have started FF. So FE, FD, FC, FB, FA, like that comes to 0. So you keep decrementing your delay and check for 0 till it becomes 0. So once it is equal to 0, 0 flag is hit. Till that, if it is not equal to 0, what you have to do, you have to keep on decrementing. So you're decrementing your delay count. So you're moving MVI B, FF. FF is moved to B register. You're decrementing the delay count. So if it is not equal to 0, keep on decrementing. Once it is equal to 0, return to main program. Return to main program. Return to main program is what? Where it left, it will go there. So where it left, here it left. Call delay. So after that, the program starts. After that, the program starts. So after that, how your waveform should be? It should go to plus 5 volts. So what do I do? MVI A, FF. So FF is your 5 volts. So FF is your 5 volts. So MVI A, FF. So once you move that FF, it moves to FF, and you have to see that. So it is outing that value out C0, out C0. So it has come to this value of plus 5 volts. Again, how is the waveform? You have to generate a delay, FF delay count. So what do? We just again call a delay. We call the delay subroutine again. So once you call the delay subroutine, go to that delay subroutine. Again, it will generate a FF delay count. So initially it was an off delay. Now you can call this as an on delay for your reference. So FF. So you are moving the maximum delay count here to FF, B register, and then you're decrementing the delay count. So 0 to FF is your delay count. And if it is not equal to 0, keep decrementing. Again, return to main program. Once it returns to main program, again it has to come to start point. Again it has to come to start point because it is a continuous square. It is coming like that. So this delay is over. This delay is over. Now again it has to come to the start point. So what do? We have to give an instruction: jump, start, jump, start. So what is it? Start Start again from the main program. So this is your start. This is your start. So MVI A comma 00. Again it goes to minus 5 volts MVI. Calling a delay. Again it calls a delay. Again go to FF. The process repeats. So a repetitive square waveform will be generated. So again you're starting 00. It comes to my FF. You're routing that value. Again you're calling a delay. So it goes to delay subroutine. FF delay is taken into account. Again you're returning to the main program. Again goes to FF, comes to plus 5 volts. So the delay count, calling a delay, again comes to 00. So this is what the process is. So this is how a square wave is generated using 8085 and 8085 using an ALP. Thank you all. Hope you all would have understood. Thank you.